Welcome to Understand the Math. In this video, I'm going to teach you how to determine where a function is increasing, decreasing, and constant just by looking at its graph. We'll start by learning what it means for a function to be increasing, decreasing, and constant, and then we'll walk through 3 example problems. When analyzing a function, we need to move from left to right along the x-axis. When a function is falling, as we move from left to right on the graph, it's called decreasing. When a function doesn't change, it's called constant. And then when a function is rising, as we move from left to right, we say that the function is increasing. When a function is decreasing, the y or f of x values decrease as the x values increase. When a function is constant, the y or f of x values don't change as the x values increase. Lastly, a function is increasing when the y or f of x values increase as our x values increase. In all 3 of these cases, the x values are increasing as we go from left to right, and when a function decreases, the f values decrease. When a function is constant, the f values stay the same, and then when a function is increasing, the f values increase. Let's now walk through 3 example problems. We're going to use the graph of the function f to determine the intervals on which the function is increasing, decreasing, or constant. In our first example, as we move along the x-axis from left to right, we can see that our function decreases, and then it's constant, and then it increases, and then up at the top, it switches from increasing to decreasing. Let's now list the intervals on which it's increasing, decreasing, and constant. The function is increasing between b and c, so we say that it's increasing in the interval between b and c. We use parentheses to indicate that we're talking about an open interval. The function is decreasing on 2 intervals. The first interval is from minus infinity to a, and then the second interval is from c to infinity. Lastly, the function is constant on the interval from a to b. Let's now look at our second example. As we go along the x-axis from left to right, we see that our function is decreasing, and then it switches to increasing, it switches again to decreasing, and then lastly, it switches to increasing. You might want to pause the video and see if you can write down the intervals on which it's increasing, decreasing, and constant. The function is going to be increasing on the interval from 2 to 3 and from 5 to 6. The function is decreasing on the interval from 1 to 2 and from 3 to 5. Notice that the function is never constant, so we're going to say none for this last part. In our third example, notice that our function is undefined at x is equal to -1, and we have an asymptote at -1. As we go along the x-axis from left to right, we start out with our function increasing, and then it bends and it starts to decrease. Then we cross the asymptote and start again from left to right, but we're on the right side of the asymptote this time, and we see that our function is decreasing, and then we reach this point down here where it switches from decreasing to increasing. Our function is increasing on the interval from minus infinity to minus 2 and from 1 to infinity. The function is decreasing on the interval from minus 2 to minus 1 and from minus 1 to 1. Notice that negative 1 is not included since the function is not defined at negative 1. And then lastly, let's just make a note that our function is never constant, so we'll write none for this part. You now know how to determine if a function is increasing, decreasing, or constant, and you're ready to try some of these problems on your own.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.